Hi, good morning, good afternoon, and good evening, everyone. I hope you're all doing great. We are back with another Global AI Bootcamp event together with Sammy and Håkan, who are going to be our speakers today. Hey guys, how are you doing?
I'm doing well. It's a cold morning, but I'm great. Happy to be here, Eve.
Yay, good. How are you, Håkan? Are you ready for today?
Yes, I'm very excited. It's also a very cold morning here in Norway, but I'm very excited to be here.
Nice. And we are very happy that you are also here. And if you have any questions regarding to the sessions or anything that is going to be heard today, please feel free to ask your questions in the chat, and we are going to visit them when the sessions are over. So before we get started with our first speaker, let me give you a little introduction to Global AI community and what are these events about. So the mission of Global AI Community is to connect AI communities across the world to share ideas and content with each other. And we want to enable AI enthusiasts and professionals to join local user groups, connect with like-minded peers, or start their own user group. If you're interested in learning about AI, you can join the Global AI community to connect with local user groups. You can join global events, access quality content, and be part of something amazing. You can connect your user group to the Global AI community to host global AI events, access event in a box content, enjoy a free Meetup Pro account, and get in touch with sponsors. And as a company, you can also reach AI developers both in your local community and across the world. You can recruit for talent and drive awareness of your brand. So the Global AI Bootcamp is a free one-day event organized across the world by local communities that are passionate about artificial intelligence on Microsoft Azure. And just for your information, there are 129 events at the same time, like we have right now. Today we're going to have two sessions. First one is going to be Sammy, who is going to have the topic that help I can't find what I need, which is going to be the cognitive services session. And Håkan Silfvernagel, who is going to talk about machine learning in the browser using TensorFlow.js. During the bootcamp, you have a chance to go to a challenge and join this link, and you can go there and you will see the Global AI Bootcamp Cloud Skills Challenge, which you can do by yourself when you have time during today and tomorrow, and you might win some good prizes. And hereby, I want to say a big thank you for joining us, and I hope you're going to have a lot of fun today. And I think it is time to get ready for our first session, right? Sammy, do you think you are ready to get started?
I'm ready for it. Let's do this. So, good morning,
Great.
everyone. Thanks, Eve, for the introduction. I guess some people might already know me. I'm also host of the AI Talks Live, which we will start soon again. Sorry. I'm a Microsoft AI MVP since April this year. Last year. Forgot we changed to 2021. I'm a partner at Arinti, which is a Microsoft data and AI organization in Belgium. So today, as the theme of the topic is help, I can't find what I need, I want to discuss first our problem. Now, what is our problem? Now, the reality of the world today is that information is constantly generated. Forbes recently estimated that the world creates over 2.5 quintillion bytes of new data per day. That's a lot of zeros after this 2.5. And data is coming in unstructured formats like PDFs, images, videos, audio files, PowerPoint text, Word documents. Now, in fact, around 80% of data in business is estimated to be unstructured. Now, just think about the amount of times you just click on your camera app on your phone and just take a picture. That picture is saved if it's in the cloud, and that's unstructured data. Of course, it might have some metadata also. Now, as a result of all that amount of data, it can cost time and money. Internally, decisions are less informed, take longer to make, work is done manually, and externally, user experience on apps can be difficult to navigate, and customers may not be able to find relevant content and products. Now, information has the potential to become an asset or a burden depending on how you are using it. So how do we apply our information meaningful to our own product or business? Well, for that, we can use knowledge mining. Now, what is knowledge mining? Now, knowledge mining solution area focuses on the core challenges, innovation across vision, speech, language, decision, and search mean for the first time it's possible for our applications to interpret unstructured data. I just need to refresh. Okay. And we'll actually have to get a more deeper understanding into traditional data as the form of text. Now, together, search and AI creates a unique opportunity and solutions for finding value within your data. Now, in the end, helping to engage customers, transform your products, empowering employees, or improve your specific operations. Now, within Microsoft Azure, there's a specific product, and it's called Azure Cognitive Search. It was called before just Azure Search, but since it makes use of a lot of cognitive services, which we will see later on, it's called Azure Cognitive Search. Now, what does it do? You see here three steps in the picture. We have ingestion, enrichment, and searching. Let's talk first about the first part, ingestion. Well, Azure Cognitive Search is made to be able to extract data from all kinds of different data files. If we're talking about PDFs, Words, PowerPoints, even if it's structured data, JSON, SQL, and so on. So being able to read that data, and then you have some kind of ETL that you're creating, a transformation or enrichments that you can add. From there onwards, you can add skills like I want to figure out key phrases within my document, or I want to figure out what's on a picture or what's in an audio fragment, and so onwards. Based on that unstructured data and with the enrichment and the capability of Azure Cognitive Search, we're generating a kind of JSON document. Now, within that JSON document, our data is not unstructured anymore, but it's structured. So we can also use it in our next step, which is search. Now, with the search API on top of Cognitive Search, you can search data within your doc data, within your unstructured data, which is actually already being processed, but also in the meanwhile on all the enrichments you did. And this again based on specific languages that you've selected. There's the analyzers the analyzer can be configured per language, and there's a lot of languages already available. Now, enough to just go into two presentations. I think it's the easiest way to just also show you what it does. Now, let's go to the Azure portal. All right, so we are on Microsoft Azure. Let me zoom in a little bit so it's readable for everyone. I think this should be fine. Okay, so we will start with creating a search service. I already created one, so we don't need to generate everything, but I want to show you from scratch what it does. Search service. Oh, sorry, create. Okay. So we need to choose or create a resource group. I'll just create on the one I've already had. We give it a name. Search Demo Bootcamp 2021. You choose your location. I'm based in Belgium, so I'll choose West Europe, which is Amsterdam. And then your pricing tier. This is already the first one, which is quite interesting. Why to choose this or the other one? If you're just trying things out, of course, you can just make use of the free storage. If the free storage has a limited size of storage, so all that data, not the PDFs and so on, but the structured data actually is saved also in another storage. Well, only 50 megabyte, it's not that much. And so with the basic, you have also 2 gigabyte, and then you can go higher. What you also see is number of indexes. And with the indexes, that's you could compare it to the kind of table in a SQL or a container in a Cosmos DB. The indexers, I will go over all these steps, exactly what it means. But what is good to know is that each pricing tier also has specific limits that you can't see here, for example. One difference between basic and standard is, for example, if I'm correct, the basic can only handle documents with, well, it can handle bigger ones, but it will only look to the first 65,000 characters, compared to the standard, which will look at the first 4 million characters. So that's already a big difference if you're working with Word documents with a lot of characters inside. Now, for this example, we're just going to take the free one. We go to scaling. Also, this is very interesting. This is all need to be set up, and you need to monitor it if it's really needed. If you're using this service on a website or in an application that is constantly used, well, then you might need to build some replicas and add some partitions to make it just all faster. Then we, of course, have our tags and usual. So I'm going to close this and go back to the one that I already built. Okay, so what we can do now is import data. This is just the wizard that we're going to follow. I will show you later on also how you can do it manually and add extra custom items to it. So import data. First, you need to connect to where is your data stored. Now, in this example, I have a blob storage with some PDF files inside. So we can say Azure Blob Storage. We give it a name, Blob Demo 2021. Now, what kind of data do we want to extract out of our blob storage? Just the contents, or do we also want the metadata? Yeah? You can say all metadata, but we can also say only the storage metadata. I prefer to have all the data, so you can still choose what you want to do. Of course, based on how much more data you collect, the longer your indexing will take. You have a parsing mode, so this is more what kind of data is in your blob storage. So if, for example, if you have JSON files or JSON arrays within your files or CSV files, then you need to take this. Otherwise, it will be just default, which is text. You have our connection string. We can choose a container, and we can actually even choose which blob folder that we would like to use within our container. So I already have this set up for my environment. Now, the next step is add cognitive skills. As I said, there is a possibility to add in an easy way elements like key phrase extraction, what's on a picture, and so on. And that's what we're going to configure in this. And you might notice that we're already see here on the top the 4 main elements within Azure Cognitive Search. And this is data, your data source, cognitive skills. Let's keep it on skills at the moment because it doesn't need to be cognitive skills. You have your index and you have your indexer. So data is connecting to your data. Now the next one is skills. It's just looking up the schema here. Okay, so in this item, we can say what kind of extra enrichments do we want to add based on the cognitive skills. So we can link, or I already created a cognitive resource on Azure. You can also use the free one, of course. If it's free, it has some limitations. So I'll just take this one, and then add enrichments. Now, in the add enrichments, again, you can give your skill a name. I will call this demo 2021. And on what content of what you have do you want to do enrichment? In this case, we have the metadata and we have the content of the file. Now we want to use the content of the file to extract, for example, people names, organizations, locations, key phrases. We want to detect language. We want to translate text always to English in case it's not English. And we want to recognize a personal and identifiable information. All these services you might already know from the cognitive services. Most of them, well, I think all of them is the text analytics functions. Yeah. So this is purely on the text. Now our next option is also, and I forgot something here, to enable OCR and merge also the images within the data. Now then we can also make use of the vision services. So if we say enable this one, we're also going to generate tags for images. So what tags can we link to a specific image, generate a caption for it, and even identify celebrities or famous people. As you see here on the right, we have field names. Now this is the part where this data, so all the people names will be added into the field people, the field organization, and so onwards. A feature that was added in the meanwhile more than a year ago already is the knowledge store. Now, the issue was before that all the data of Azure Cognitive Search was saved within the search environment. Now, if we want to move that to, for example, to make use in a data warehouse, because sometimes that might be interesting, we had to extract each time from the service through the API to get that data. Now, with the knowledge store, there's a way to save that data immediately in another blob storage as JSON files. So we can project it into a table storage or purely as files. What we also can do is save all the images that we find within our storage, within our documents, immediately to a separate blob storage, so we would be able to make use of them within a web application, for example. Microsoft was so friendly already to to even generate a Power BI report, which is linked if you click on everything. That is linked to those blob storage, so you can immediately start reporting even on those services. So which is really cool. So this is the skills, and the skills you're gonna say, I want to do this kinds of transformations. That's why I was saying it's a bit like an ETL service. Now the next step is, where are we going to save that, and in what structure are we going to save that? And that's our index. So let's validate this one. All right. So again, we can give our index a name. We'll call it demo 2021 again. We need to give it a key. So each file needs to have, each item within your index needs to have a key. This could be your path name, because that should be unique. You can also define something else if you want. You have a suggestion name and then a search mode, which there's only one. At the moment, you can just call this suggester. That's it. Okay. Now your index. As you see, we have a list of fields here. Now, this is very important to know that all the things that you will configure here, once it's configured, you cannot change it anymore. So keep that in mind. Now, per column, if you could call it column or field, you see here retrievable, filterable. So these are the options on top of those fields, what you can actually do with it within Azure with the Search API. Now, retrievable, I guess that makes quite sense. we want to just get that data back. Sometimes that's not important to get the data out, so that's up to you to decide. Filterable is not the same as searchable, but filterable, it needs to be exact matching. So keep that in mind. Sortable, okay, that makes sense. Facetable is something different. With facets, you can compare it with, you set up a list of, like let's say an Amazon shop. You go, you search for Microsoft Surfaces, and then you get a list of, do you want the Surface with 16 gigabyte, 32 gigabyte, 64 gigabyte, and so on. So these items are like filters that you can use. Now this part can be taken out of your content and added in facets and as a separate value, as a separate set of data that you can use within your web application. And then, of course, we have searchable. By making use of searchable, you can also connect an analyzer to it. Now, depending on the language that your data is in, you have all different kinds of analyzers. So you have just the classic Lucene. Then you have per language, most of them you have it's for Microsoft and on the classic Lucene. I personally love to use the Microsoft one because I see it's really a good one and there's quite some differences in between. And then you have the Suggesture. With Suggesture, it's actually to do, for example, an autocomplete functionality. Some good things to know already is that the analyzer generates other data that you can't really see within your environment. For example, it was an issue I had this week with a project at a customer, is that I was searching for not a road, for example, but I want to have an exact match of not a road. But most analyzers see not as a word that is not so important, so it removes it. So I had a road, and because of that, I had too many matches. So we're still looking in different ways also to improve that. Okay, so now we know how to save our data and in what way or in what structure it needs to be saved. Now we also want to check and when does it need to be processed, or what files do we still want to filter some files out, and that's in our indexer. Again, we give it a name, demo 2021, and we can set up a schedule. And we can do hourly, daily, or custom, whatever you would like. We have some advanced options. If you want to encrypt the keys, what happens when something fails, how many fails can happen per batch, what's the batch size, what extensions do you want to load. And again, also here you can select what data to extract, content and metadata, only metadata, and so on. And then parsing mode is only default. And then you can click submit. The indexer will immediately kick off and start processing all the data in your blob storage. And that looks something like this. Just grab a drink. If there's questions in the meanwhile, don't hesitate to ask in the chat. I'm following this up also. Okay, so we have our indexer. Let's start with that. I loaded 20 files, and you see all of them were successful. It's good to know all of these items, the skill sets, the index, the indexer, and the data source. They're all configurable via JSON also. Why is this good? Well, some functionalities are not possible within the wizard we just saw. I will give you some ideas later on that. And so we have the full same settings here. We have our field mappings, and actually we see here, okay, this people needs to be linked to people and so on. More about that later on. We have our data source that was set up, our skill set, and our index. Now, how does our index look like? Of course, we had set up all our our fields already. Now, if we would just search here, we get all our data back, which is saved in the index. Now, what we see here is our content. I'll scroll down because it's a long document. We have our storage path, which is base64 encrypted. It recognized people, it recognized organizations, it recognized locations, it recognized key phrases. So these are all important words within the documents, quite a list. It recognized the language as English, the masked text. Everywhere, excuse me. Everywhere where you see stars means there was some personal information. So to make a GDPR proof, for example, this is a good way to remove all that data. See, there's quite some information. Boom, boom, boom. Scroll down. Okay, then we have our image tags. Everything, everywhere where OCR is found, image tags. And then we also have our image captions. This can still be cleaned up in different kinds of ways, so you can also use it immediately. And then this is the PII identifier. So where was something found? Okay, so this is how we all can do this within a wizard. Now I want to show you also a result of how things could look like. Within Arinti, the organization I work for as a partner and a senior consultant, we built a service called Tafuta where we can actually just connect the cognitive search to a web front end. Because at the end, Azure Cognitive Search is an API service on the back end, and you want to show it to the users, of course, also. Now, we created something like this here, where you can just search for what you're looking for. So if I look for Cosmos, for example, I will get a list of all the items where Cosmos is talked about. This is a highlighting function that is also added into the service and that you can use through the API. How do you do that? Let me go. Now, the query string, you can do it through a query string or through post requests. There's also the Azure Search SDK. It's fully, well, you can change it in many different ways. Let's say I'm looking here for Cosmos, and then I will get the same kind of, I'll zoom in a bit. We'll get the same results. Now I can actually also add count, for example. True. So we see there's 8 documents, should be the same as here, 6. Okay, need to check why that is the case. Yeah, it's not looking on the same data set, sorry. I can say I only want to see, for example, the file path. Is that the correct name? Or let's say the language. We can select which fields we want to see. And you will also notice that for each document, you get a scoring back. This is not a percentage of how accurate this is. This is a scoring based on the amount of documents and giving which one is more important than the bottom one. So to give a way for you to order them and show them within your application. So we have select language. You can even say my search field, for example, equals contents. So it will only search or use the analyzers of the content field, and so many other items that you can do. You can filter, let's say, language equal to English. Oh no, they're all English, but look, this is a good example of when you didn't set up your fields well. Then you get issues like this. If we go back to our fields, you will notice that nothing has been set up as filterable. So I can't even use those fields to do exact matching. So you need to really configure those things. Go back to the example. As I said, facets are specific items that you can show, for example, in a filter, and that's what you see here. So, for example, in this list, organizations and locations and so on can be used as facets, and it's also an easy way to filter on them. So you only want organizations with availability zone is also in the documents, so you get to. Something to also mention, it's something that I've had issues with before, is that the counts that you get back on a facet, and so it will return, for example, for availability zone or for here Africa, Israel, that there's one document. This one might not always be correct, and that's because of the way how Azure Search is looking through those documents. If they would need to give you an exact match, the queries would take way longer, and then that's again not good for your performance. But it gives you an estimate, and it's also always close by to it. So, and this is only an issue when you have a lot of documents. I have at customers where we're running this with a couple of thousands of documents, and then it starts to become that the numbers are not always correct. But it's not really an issue if you can explain it to your customer. Okay. A feature that was also added, it's still in preview though, is more like this. Now, what does this do? Reset all. Actually, based on the keywords of this document, it will look and search in your data set for other documents that are like that. So that way, you will have another list of, likewise documents. You see also here we have the scoring, just to give an idea. Of course, you can also just show the full document of, this is actually the whole content that got extracted. And you could even add functionalities like creating within your storage. You can add items to add comments, for example, manually. Something here we did that the user can say, hello, this is Sammy. If I would look now for Sammy, I will also get this back because it's immediately analyzed and you can use it within your search. Okay. So we have our facets, we have our more like this. Other functionalities that might be very important is that the analyzers are built on a general language and not on specific work vocabulary. Now, if we will go, for example, there's a synonyms. This is also just calls to the APIs we do. We can build synonym lists. So here I'm saying that Microsoft is equal to MSFT, or artificial intelligence can also be recognized as AI. So in case I'm looking now for MSFT, it actually searches also for Microsoft. So these are synonyms. Good. Back to more Visual Studio coding to go more in depth in certain items. Let me share, just close this. All right. Good. Now I have a solution here on Visual Studio where I have created for each, let me close all tabs here. I created the setup for building this on Codewise. So if we start with our data source, well, we have a connection string, we have a container we select, and then the query could be the folder. We have our skill sets, which is actually, as I said, all the steps that you can switch on in the wizard, but here in a Codewise base, where we say, in this case, for example, we want to do the key phrase extraction skill. You can give it a name, a description. what's the default language? Because this is important for the key phrase extraction, that's just some the service of that API, that it needs a language code, because otherwise it would need to do a second call first to the language API. And you say, what content am I giving as input that needs to be analyzed? So each of these standard skills have a list of inputs and what comes out. So in this case, we have our text, and the input is our document/content. Now, we have our entity recognition, where we want to recognize specific categories. Again, we set up a language. We could as well start it with a language recognition skill, and then use that element to go in our next steps as input. So we have our input here also, and then we have our output, which is different values based on what the categories are that you defined. You have an OCR skill, image analysis skill, and then this is an interesting one. It's a custom entity lookup skill. Now, what is that? In the above mentioned skills, for example, the entity recognition skill, we are recognizing organizations, persons, and locations within that document. Now, what if there's something that you actually want to recognize? Maybe there's a specific list of products or specific vocabulary. There was a project we did for a research center here in Belgium, and they wanted to recognize the elements, and like if it's oxygen, if it's I'm bad in science, all these kinds of things, but also different processes that they invented or that they are working on. So we created a list for them with all these kinds of things. It's actually just a CSV-like document that you define in a storage container, and then you can configure again, this is the data that I'm sending, and I'm returning this custom entity. And then you have other skills that you can use for configuring specific things within your field. Now, in this case, for example, I'm setting a document type. There's no way to exactly set a value to a field, like a fixed value. So you can trigger other skills to still do that. So in this case, I use a conditional value. When it's true, then the value needs to be set to document. When it's false, yeah, then set it to 0, but it's always true. And then my output is document type. You can configure your cognitive search key, and then of course also your knowledge store. And in this case, I'm projecting all the images I find in this document and save it into my storage account. So as I said already, for example, this conditional skill, this custom entity lookup skill, they are not in a wizard, so you need to do it by code or with the Azure Search SDK. But I don't think the custom entity lookup skill is already in the SDK, because these are new ones and the SDK is not updated yet. So we have our skill sets, then we have our index. And here we're actually configuring, just as in the wizard, but then of course in a code way, what fields we have, what type of data is it, and then all the different things. But what we can as well have, in this case, let me show you by a demo. This is also a good way to show the power of the analyzer. For example, I search here for boot, but it actually looks for boot, but also boots, because the analyzer knows that it needs to do these kind of mappings. Now, in this case, I have no idea if I shared my audio. This is based on MP3 files. MP3 files and video files are by default not possible to analyze with Azure Cognitive Search. But what you can do is build like some kind of pipeline outside of Azure Cognitive Search to make use of the other cognitive services to do speech to text, for example, or using the video indexer to extract data and then create a JSON file that you can load into your cognitive search to have one nice solution where all your data is saved. So in this case, we have all our data and it can still be searched in. All right. So yeah, this is what I want to show. So you see here I've split up my audio fragment in different phrases, but I also want to save it like that so I can reuse it. Now within you're setting up your fields, you can also create complex types. Now with complex types, it's a JSON object, so you can have an object with another object inside or an array of objects and so on, and deeper and deeper and deeper. So in this case, I have audio phrases, which is a collection of complex types, and each audio phrase starts, for example, the start time has a speaker, has a phrase, which is a text, and so on. I could have here another complex type that gives back other data. And then we have our organizations. You also see here a collection type. So this is an array of string elements and so on. This is another complex type. This is linked to our comment sections. There we have comment ID, you save the user, create it on, modify it on, and so on. We configure our suggestion, and then we have some other items that, if I'm correct, yeah, you can still do it on the website also, is your scoring profiles. What are scoring profiles? Now, if you're using Azure Cognitive Search, for example, on a website for finding hotels, and you're looking for hotels in the area of Paris, well, then you could use that location or your own geo coordinates as part, as like an extra item to your search. So it will score the hotels closer to that area higher than all the others. Or you could use it to show documents that are newer, more on top, or give them a higher rating than the older documents. That's the index. Then we have our indexer, and this is, as I said, it's the same as on the website. In this case, I'll just go to documents. And we say I only want PDF files. In this case, I want to generate images. We have our metadata that can be mapped to our fields. And then we have our output field mappings. This is actually what comes from the index. For example, content, we want to save in our contents, but then more our locations and so onwards. Also here, there's a way of caching. This is also a new functionality that was added, well, not so long ago. What does this do? It's also something that you can't configure within the wizard. With caching, now imagine if we go back to those custom entities, you have your own product list that you want to recognize. Now, what happens when a new product is added? Well, before you had to re-index all your files and to run that skill. Now, with caching, it keeps track of what has been changed in your skill sets, and you can actually say, I want to rerun, but check also in my skill set what actually has changed, or I also only want to rerun that specific skill. So only you don't need to load everything again, which makes things easier. And that's in the meanwhile, we have everything. So we discussed our indexer, index, our skill set, and our data source. Okay, good. All of this give the complete functionalities of Azure Cognitive Search. There is a way to also create a demo app, which is quite nice, but of course it's not customized to your specific needs. It's quite general. You can start always by creating everything in the wizard and then look at the index definitions, copy it, and write it to your own into your own solution. we have that for all the things. You can also debug a session, which might be quite handy if you can't really figure out why an indexer is running errors. Of course, you have your Search Explorer to already try certain things out before you use it within a web application. As I said, this is a REST API service, which is actually also the back end of the Q&A maker, where the Q&A maker uses an extra layer on top of it to do more the NLP stuff. So that's also good to know that it's a service that really is used a lot. Okay. Good. Are there any questions? Please don't hesitate to ask. I'm also still available on my Twitter handle if you would like to know more about this.
Of course, we
If
can
you were
see
talking
that.
with you or not in the call.
Yeah, I just thought I'm just hiding in the background because yeah. But so the question is really that I was thinking that this search functionalities are also the back end of the Q&A maker. But let's not think about that for a second, because my question is that, on your opinion, and given all the information is now clear and so after thinking about it a lot, what do you think? Which is the best? Which is that business scenario that this service can be used the best? Without thinking about the Q&A
different
maker.
ways. So you can use it to enrich your own data set. I have a customer where we have a SharePoint site. Well, there are 3 SharePoint sites that we sync to a blob storage that we enhance with the cognitive services through these skill sets. So they have even more information, and then they have one place to search through all their data, because we also load in, for example, their dynamics data, link it to those documents. So you can really make it enhanced. Another functionality would actually just be for on a website, on a shopping website. So you can search for products. You have your filter lists that are generated, those facets that you can use. That's kind of the 2 scenarios that I see the most used.
Thank you. I'm not sure if we have more questions from the from the attendees, but maybe until we wait for the rest of the questions, let me also say a big thank you for Sammy for this nice and interesting session. And please follow him on Twitter, which is shared on the screen right now. And also, if you would like to join us at other events and sessions in the future, please follow us with the Twitter handle that is on the bottom of the screen on the right side. And you can also find the website of Global AI Community, where you can find all the information that I mentioned in the beginning of the stream. Yeah, still no questions yet.
That's not a problem.
Then I think you know why. It's because you did so well, so like very clear, right? So it was very understandable what you were talking about. So all right, then before we move on to the next session, I would like to share one more information with you. And for that, I'm going to show my screen for a second, because there is a challenge that is available for you also within the Global AI Bootcamp. And this is this custom vision challenge lab that is prepared for you to build your own model with the use of Azure Custom Vision. And then your model can compete with our models. So it would be cool to join us and play with us. I'm going to share the link as well in a second. And you can go and try this out. If you click on the hands-on lab, you can see a lot of information that might be, so how you can build your own model as well. It's like all the steps are included in that. All right. So let me invite on stage Håkan, who is going to talk about machine learning on the browser with TensorFlow.js. Hi, Håkan. How
Hello.
are you? Are you ready?
Yes, I'm ready.
All right. Then take it away. Good luck.
Okay. Thank you so much. So welcome to my session here where I'm going to be talking about how you can run machine learning in the browser using TensorFlow.js. But before we start, I'm just going to give you some background information about me. So I work as a manager for AI and big data at the Norwegian consultancy company called Miles. And my background is I've been working with human-machine interfaces for process automation and robotics. And my educational background is a master's degree in electrical engineering and also a master's degree in behavior science. And I'm also quite involved in the local user community here in Oslo, so I'm part of the Norwegian.net user group. I'm also part of Oslo AI, and I am a Microsoft AI MVP. And I'm also, together with Eve, founder of AI42, which is an online AI school. But we're going to talk more about that later after my session, so I won't be saying much more about that now. And if you want to follow me, you can see my social media links here on this slide. But now the topic for today is machine learning with TensorFlow. So this is the agenda. First, I'm going to be giving you some basic introduction about machine learning, just so that we're sort of on the same page. And then I'm going to go more into TensorFlow in general, and then we're going to go more deeper into TensorFlow.js. And we're also going to have two short demos. One is where we will use TensorFlow.js and build an application from scratch in the browser. And then we will use an already trained machine learning model in order to build an image classifier. The first thing is, what is machine learning? So there's a definition from the 1950s where Arthur Samuel said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. But you can also say that machine learning is sort of a pattern recognition in historical data. And we have some different types of applications here of machine learning. You can use machine learning for prediction, or you can use it for building recommendation systems, you can use it for clustering, or image, text recognition, or speech recognition. So one way of machine learning that we will have a look at today is called supervised learning. And the idea behind supervised learning is that you have access to historical input, and you also have access to the result historical output. And by using these, you can build a model, and you can train it up so that when this trained model sees new data, real-time data, it can give back a recommendation or a prediction. So that's what we're going to be looking at today. But as I said here, machine learning has been around since the end of the 1950s. And the question is, why is machine learning and AI such a hot topic today? So there are a number of enabling technologies. So one of them is that we have access to sensor technology so that we can have lots of real-time data. And we also have access to big data solutions so that we can load and transform our data in the cloud. And we also have machine learning algorithms that are highly scalable and that we can use through API and services in our own applications. And just for completeness, I will also say a couple of words here about what types of languages we can use for machine learning. So basically, you can do machine learning in any type of language, but you don't really want to start from scratch. So what you want to do is you want to work in a language which has a lot of tools and libraries that you can use. So two of the most popular languages is Python and R. And traditionally, Python has been more popular among people with a computer science background, whereas R has been more popular with people coming from a statistical background or from university or academia. But now when we know a little bit more about learning, we can go into TensorFlow. So TensorFlow is an open source library developed by the Google Brain team, and it works through something called tensor operations. So I'm going to be describing what a tensor is in a short while. And one of the main things here is that TensorFlow supports distributed computing, which is especially important if you want to run neural networks or deep learning. So what is a tensor? So tensor is something that comes from the world of mathematics. So we have different concepts. So one is scalar, which is a real-time number, or you can have a vector, which is a collection of numbers, or you can have a matrix, which is like a two-dimensional vector of numbers. Or you can have a tensor. So a tensor is a container where you can store either scalars, vectors, or matrices. So TensorFlow is a Python library, so you can use it here in Python. So you can just import TensorFlow and you can start up a new session. And then you can define two constants, a and b, and then you can run a plus b and print it out on the console. But now what we're interested in, we want to run TensorFlow in the browser. So then we will use TensorFlow.js, which is a JavaScript library here. So what you can do with TensorFlow.js is you can both train and deploy your models in the browser and using Node. So then we've come to my first example here with TensorFlow.js. So let me switch over here to the browser. Or actually, let me switch to Visual Studio Code. So here, what we have here is we want to build a machine learning application in the browser here. So we have a simple HTML page where we're just importing two libraries. We're importing the TensorFlow JavaScript library in a minimized version, and we also import the TensorFlow JavaScript visualizer also in a minimized version. And then we will write all of our application code in a script.js file. So right now, this JS file is just printing out on the console log, hello TensorFlow. So if we run this in our browser, it will look something like this, hello TensorFlow. But we also need to have some sort of a problem that we would like to solve with machine learning. So the first thing that we need to have is we need to have access to data. So luckily for us, we have here some car data in the form of JSON file. So if we look through this data, we can see that we have some statistics here. We have the miles per gallon, and we have the number of cylinders, the horsepower, and the year it was made, and so on for a number of cars. So what we would like to do first here is we'd like to load this data into our web application. And then what we are interested in is to find out, can we use miles per gallon and horsepower and try to predict one data from the other. So the first thing that we want to do is we want to load this data. So let's go over to Visual Studio Code, and then we'll add the function. So this function, what we do is we do fetch on our JSON file, and then we clean up the data a little bit. So the only thing that we're interested in is the miles per gallon and the horsepower. And then we do some filtering, so we filter out the null values. And then we just return the clean data back to our caller function. And then the next thing that we would like to do is we would like to be able to visualize this in the browser. So we'll define a run function like that. So what we do here is we first get the data from our JSON file, and then we map it so that we get on the x-axis, we get horsepower, and then on the y-axis, we get the miles per gallon. And then we are using this TensorFlow visualization component that we were importing. So we can just use a pre-built function here, TensorFlow visualization .render, and then scatterplot. Because what we would like to see is there any sort of correlation between horsepower and miles per gallon? And then we'll add more code here as this example evolves. And then we add an event handler so that we can run this function when the DOM content has been loaded. So we save this, and then we go back to the browser, and then we go back to the screen here, over here. And then we can see here that now by using this pre-built component here, we get a scatter plot of miles per gallon here on the y-axis and horsepower here on the x-axis. So the question that we wanted to see is there any sort of correlation between miles per gallon and horsepower? So because what we would like to do is we would like to be able to predict a new miles per gallon on a horsepower value. So as we can see here, there seems to be some sort of correlation between these two data points. And that is a good thing, because if this data would have been scattered all around the plot, it would have meant that there is actually no correlation. So then there is nothing for our machine learning model to learn. So then it's not a good problem for a machine learning algorithm. But now, as we can see here, there seems to be some sort of correlation. So that's a good thing, because that means this is a good candidate for a problem to be solved by machine learning. So the goal here is that we would like to be able to train a model where the input is horsepower and then our prediction is miles per gallon. So that means that we have a one-to-one mapping. So we'll use these data values that we have here and we will feed them into a neural network. And this neural network will learn from these examples so that it will be able to predict miles per gallon from a new horsepower value. And this is an example of supervised learning that we were looking at in the PowerPoint presentation. So first thing that we want to do here is we want to define the model architecture. So in machine learning terms, that means that we want to decide what kind of algorithm should this model use in order to compute its answers. So in a machine learning model is an algorithm that will take an input and it will produce an output. So in this case, we will use a neural network. And here the algorithm is a layer of neurons with weights that will decide what the output should be. And during the training process, the algorithm will learn the best values for these weights. So let's add a function here to our script where we can create the model. If I go back to Visual Studio Code, and then we add function. So in this function, we create something called a sequential model here in TensorFlow. So we can use already existing function here in TensorFlow. So we can use the TensorFlow sequential to define our model. So the sequential model is one of the most simple models that we have in TensorFlow. And it's called sequential because its input flows straight down to the output. But of course, there are much more complex models so that you can have multiple input and multiple output, and you can also have branches in your model. Then we add a single input layer to our model. And this is connected to something that we call a dense layer. So dense layer is a type of layer that multiplies its input with a matrix, and that's what we call weights. And it also adds a number called bias to the result. And this is the first layer of the network, so we need to specify the input shape, which is, in this case, it's 1 because we only have one number as an input, and that's the horsepower. And then we need to define the units. So the unit sets how big will the weight matrix will be in this layer. So here we set it to 1. So that means that there will be one weight for each of the input features of the data. And then we create an output layer where we set units to 1 also because we want to have one number as an output. And then the next thing that we want to do is we want to create an instance of this model so that we can use it. So let's go to the run function. Then we're using an inbuilt function in the TensorFlow visualization component where we can show something called a model summary. So let's run this in the browser. So here we can see the model summary. So we can see that we have 2 layers, and we can see what the layer names and what is the output shape and how many parameters there are. So next is that we would like to prepare the data for training. So one thing with the TensorFlow library is that it only works with tensors. So somehow we need to convert this car data, the miles per gallon and the horsepower, we need to convert this into tensors. So let's add a function here to our script where we can convert this to tensor data. So in this function, we are doing two things which are best practices when we do machine learning. So the first thing is that we shuffle our data. And the reason for that is that when we do our training, we will divide our data into batches, into smaller subsets of data. And when we train, we want these batches to be as representative as possible for the whole data set. So that's why we would like to have data from all across the data distribution. So if we do this shuffling, we're sure that we will get data from all different types of places in the distribution. And this has a number of advantages. So one of the things is that our machine learning model will not be learning things that are only dependent on the order of the input data. And also it will not be so sensitive to structures in subgroups of the data, because it could be that maybe the first half of the training data will have high horsepower for one or the other reason. And that's not the relationship that is very representative for the whole data set. But now when we do shuffle, we will avoid all of that. Then the second step that we do is we convert our data to tensors. We just use a pre-built function again called TensorFlow tensor2d, and with the input and the lengths of the input. So we'll have one input tensor, and we will also have one label tensor. So the label tensor is what we call results or output. And then we are doing something called normalizing. And the reason that we want to normalize our data is that a lot of the internals of these machine learning models, they are designed to work with small numbers. So that's why we want to have a normalization so that we get our data into the range from 0 to 1. And this is something called min-max scaling. And then we are also saving the input max and the input mean and the label max and the label mean. And we return that data back. Because when we're done, when we're through, when we made our prediction, then we need to be able to scale it back to the original scale. So that's why we need this input max and so on. So next step is we would like to be able to train our data. So let's define a function here for training our model. And so in this function, the first thing that we do is we prepare our model for training. So first we need to compile our model before we can train it. And we also need to set some parameters for this compilation. And one of them is the type of optimizer we want to use. So the optimizer is an algorithm that will decide the updates to the model as it sees new examples. So there are many types of optimizers in TensorFlow, and here we picked the Adam optimizer because it's quite effective and it requires little configuration. And we also need to define the loss function. So the loss function is sort of a quality function that will tell how well is the model performing when it learns from these new batches of data. So here we are using the mean squared error to compare the predictions made by the model with the true values. And then we set the batch size and the number of epochs. So the batch size refers to the size of these data subsets. So there are common batch sizes can range in anything between 32 to 512. And there isn't really any ideal batch size for all problems. And it's actually a science in itself to decide upon the batch size, but this is a standard batch size that we will use. And then epochs is the number of times that the model will be looking at the entire data set. So here we will take 50 iterations through the data set. And then finally we start the training loop by calling model.fit. And we have also defined a callback, and in this callback we're calling this TensorFlow visualization component so that we can monitor our machine learning model as it sees data for each epoch. and it will plot a chart here for the loss and for the mean square error. So then it's actually time to do some training here. So let us add this to the run function. So, first we convert our data to tensors, and then we extract the input and the labels, and we put them into this train model in order to train our model. And then we are just writing out on the console log when we are done training. So let us run this in the browser. So we can see here that over here we are using this visualization component in order to plot our loss function and our mean squared error. And we want this value to be as low as possible. And we also define that it should stop after 50 epochs. So you can see here that the loss function is 0.025. And then it's also written at done training. So now we have a model and we have trained our model. So then what we want to do now is we want to be able to use our trained model in order to make predictions. So then we would like to test our model here. So let's add a new function here to the script for testing our model. Yeah, so what we're doing here is first we're defining 100 new examples that we will feed into our model. And we're also doing some reshapes so that we get it into the same shape as we had originally. And then we are doing, we're calling a model.predict to get our new values, our predictions. And then we need to do an unnormalization. So that's why we were saving this input mean and input max and label mean and label max so that we can scale it back to the original scale. And then we just use this TensorFlow visualization component again in order to render a new scatter plot where we can show the model predictions and the original data. So then finally we need to run this function in our script. As over here, we're just running this function that we were just talking about in order to test our model. So let's go back to browser. I should also say here that, since this is just an example here, we are running this training of our model for each time we run our example. But in a real world example, you don't need to run training for each time you run your machine learning model. But the important thing here is that you are able to monitor your machine learning model so that you can quickly detect if it deviates too much from the original data. Then probably you need to do some retraining of your model and you need to deploy your model once again. But over here we can see, so here we can see that it's tried to estimate or do a prediction with a line here. And this is not a particular good prediction here. So the question is, can we do something about this? So so the answer to that is that we can try to use a new model here, because as we can see, this prediction is a straight line. So it doesn't take into account this non-linearity that exists here in the data. But maybe if we add a new model, we can take that into account. So let us go back to the place where we define our model, which is over here. And then let's comment out this thing. this. Then we add some new code here. So what we do here is we create a sequential model, and then we add 2 more layers between the input and the output layer here. And so by doing this, we can take into account this non-linearity that we think will help our model and our predictions. So you just save this, and then we go back to the browser, and then we run this again. So here we can also see in the model summary that it has been updated because we are using a new model. And you can see that it has many more parameters. So it has 128 parameters for the first hidden layer, and for the second it has 4,160 parameters that can be trained. And then we can also see here that it reaches a much lower loss function, and much earlier too. So it reaches almost after like 5 or 6 epochs, it has reached its minimum value. And then if we look at our predictions, we can also see that this new model is actually able to predict this much more accurate than our first model was able to do this. So that concludes our first example here. So what I would like you to take away from this is that now you're able to, because you saw that we were starting from basically nothing, we were just importing the TensorFlow JavaScript library and also this visualization component. And just with these 2 things, we could train, and we can use our machine learning model, and we could also use it to do some data analysis. As you can see over here, we can use it to do plotting and to investigate if there are some correlations in our data. And we could have a model summary, and we could also do training and monitor the training, and finally we could plot the result of our machine learning model. So it's quite versatile, and it doesn't require you to do so much coding, because you can make use of a lot of pre-built functionality. So now let me go back here to the PowerPoint presentation. So this is one way that we can use TensorFlow.js, but another way is that we can actually use existing models, and we can import these existing models into TensorFlow.js. But in order to do that, we need to be able to convert it, because TensorFlow.js is only working with a format called a layered format. So we need to be able to convert it from a different format into this layered format. But luckily for us, there is a bash or a command line utility that we can use. So an example here is that we're converting a Keras H5 model to a TensorFlow.js layers model from the bash or the command line. And we can also use it in Python, so there's also a Python API. So in this case, we're importing Keras, and we're importing the TensorFlow.js and TensorFlow. And then we load this Keras model, which is called MobileNet, and then we save this Keras model as a simple model, or we convert it and we save it as a simple model. And then in our JavaScript application, we import TensorFlow.js, and then we can just load our model by using TensorFlow load layer models. And we will have a look at this in a short while in our second example. But let's talk a little bit about why would we want to use TensorFlow.js in the beginning. So one of them is that you don't need to learn another language like Python or R. So this opens up a whole new world of possibilities and opportunities for everyone who is a web developer who are familiar with JavaScript. So now they can actually use machine learning without having to learn another language and in another environment. And another benefit is that you don't need any round trip from the client to the server. So as we saw here, everything is done on the client. And the user data is local, so it can prevent man-in-the-middle attack. So you can say that it has a higher grade of security. And in addition, you will use the browser as the user interface. So the browser is highly interactive, and it's easy to use. And you also have easy access to sensors like the webcam or the microphone. And as I said, you can use pre-existing models. So basically, either you can run existing models, or you can do some retraining of existing models, or you can develop machine learning from scratch with JavaScript, as we did in the first example. And over here we have some examples of these pre-existing models that we can use. So there are already models for image classification or object detection or sentence encoding and so on. So there are lots of models that you can use out of the box. So now I'm gonna go into my second example, which is an image classifier. So let me go back to the browser. And let me show you how this is done. So let's reload this. So the first thing that you do is you choose an image here, and then you want to be able to detect what is in the image. So then we can select, so now we select this mobile net that we're talking about, and then we can push predict. And then we can see that our machine learning model is predicting that this is a strawberry with 99.9% probability. So let's have a look at how this example has been implemented. So let me switch over here to Visual Studio Code. This is Visual Studio Code, and this is just the front end. So we have some model selectors and some drop downs and so on. And then, as you can see here, we're also importing this TensorFlow.js library, and we have a class here called ImageNet classes. I will come back to what that is. And then we have the predict.js. So in the predict.js, that's where all this machine learning will take place. So in the predict.js, we have an image selector where when we select this image, we read the file and we read it as a data URL here. And then when we call our model selector, we'll call this load model with the name of the model. And then you can see here that then we're using TensorFlow load layers model. So this is one of these pre-built Keras models. The mobile net is a Keras model that I was converting through a command line application. And then what I got back was this model.json, and I also got back some shard files here, some binary files here that describes the machine learning model. And then you can see I've saved them in a library called MobileNet, so it will just look into this MobileNet library and it will use this model.json file. And then after that, when we click the predict button, then it will the first thing that we need to do is we need to do some pre-processing, because remember that TensorFlow is only working with tensors. So we need to convert our image into the tensor format. But then when we have it in the tensor format, we can just call model.predict with our tensor, and then we will get back our predictions. And then we do some simple mapping here, so we get back the top 5 predictions from our model. And this is where we'll use this ImageNet classes file that I was talking about, because from this MobileNet model, we will only get back a probability and then an index, a number. So this index is actually an index into a file here, into a dictionary, so that then we need just to convert our index into plain text so that we can show the plain text back to the user. So that's basically it. So you can see here that we didn't need to do, you can see this is all the code that there is. So we didn't really need to do that much at all in order to use this pre-built MobileNet model in our own application. So, and this, I should also say that this goes for any type of model. So if you have some data scientists that are used to work in Colab or in Jupyter, you can also convert their model into this format and use it in your web application. So let me go back to the presentation here. So now I'm going to take something to drink. So now I want to finish this presentation with some examples from the real world where some companies has been using TensorFlow.js. So one example is from Uber. So Uber, they have made a tool called Uber Manifold, which is a visual debugging tool which is using TensorFlow.js. You can also have a look at it on the GitHub link, which is on this slide. Another example is from Airbnb. So they have done something called the identity document detection. So when you upload images on Airbnb of your apartment, then it could be that maybe you've forgotten to remove your driver's license or your passport or anything which might have sensitive information. But then Airbnb, they are running a TensorFlow.js application in order to be able to detect this, and it can warn the user that there is some personal sensitive information in this picture. And then finally, we have an example from the world of music. So there is a library called Magenta, and Magenta, they are using machine learning models in TensorFlow for music generation. And you can have a look at this link if you want to know more about it. And then finally, I have some references. So the first one is the TensorFlow official documentation, where there are many tutorials and good information. And I would also like to recommend the Coursera course, which is called Introduction to TensorFlow. And if you want to know more about this image classification example, you can have a look at the Deep Lizard, which is a YouTube channel that talks more about that. Or you can have a look at this as one of the code labs with a regression example that I can also recommend. So if you have any questions or any comments, you can always reach me on Twitter, where my Twitter name is Agrevlis, or you can reach me on the email address that you can see on this slide. So for that, I would like to thank you for tuning in, and yeah, thank you so much.
Thank you a lot, Håkan. It was a great presentation and really exciting. It was always nice to see new ways of doing machine learning, and it was really nice. And we also have a question here that if someone wants to get started with TensorFlow.js, where the information and the first steps can be found, maybe you could share some links where to.
Yes.
Yeah.
I can post some links in the chat here.
Thank you. Thank you. Do we have any more questions? Yeah, until we wait for the questions, remember to follow Håkan also on the handle that is shared on the screen right now. So that's on Twitter. And also follow Global AI community that you can find on the bottom of the screen on the right side. The Twitter handler is Global AI community, and the website is global.ai.community, where you can find all the information that we mentioned in the beginning of the session about Global AI community. All right. If we don't have more questions, shall we move on? And let's have a talk about AI 42.
Yes. So let me switch presentation here. So like that. Yeah, so maybe we should give a little bit of background here. So it's me and Eve who are the founders here of the AI 42. So Eve, maybe you want to say something about why did we start this? What is the meaning with AI 42?
So our motivation was that we figured that there are not many or not very well usable content there are for those who want to get started on the field of data science and AI. So we thought we gather together and get a lot of experts in the field to come to teach us, and they are going to show us different topics. We start with mathematics, statistics, probability, and we walk through the whole path to, in the end, be able to build your own machine learning model. Håkan, do you want to talk a little bit more about how the setup is?
Yes. Yeah. So the way that we will do this is that we will stream. So we're streaming both to YouTube, and we stream to Twitch and to Twitter and to Facebook. So we do that 2 times a month on Wednesdays at 5, and we will do that at least throughout all of this year. So we'll start with the introductory topics that Eva was mentioning with mathematics, and then we will gradually move over into statistics and probability, and then you will learn about Python and learn about R, learn about databases, learn about SQL, and then more about toolings like Power BI or Databricks, and more advanced sessions like reinforcement learning or explainable AI, for example. And in addition to these more theoretical sessions, we will also have some workshops where you will be able to put your theory into practice.
Yes, and I also would like to mention that we are in close collaboration with different meetups and communities all around the world. So we try to get speakers from their communities as well, and to share the knowledge with everyone. I think that's very important. And then there is another important thing that is very good for you as well, because just because of this cross collaboration, you can connect with people who has the same interest like you. So you can grow your network in the field of data science and AI. Did I forget something, Håkan?
No, I don't think so. We will share these links in the chat here, but you can reach us both on YouTube, on Twitter, on Facebook, and on Instagram. And we also have our own meetup where we will publish every time we have a meetup planned. So so I would suggest, if you're interested, to sign up for our meetup and to subscribe for our YouTube channel so that you don't miss out on anything.
Yes, and one more heads up before we go on and before we get there. So we are going to have a web page as well of AI42, because we would like to share all the resources that has been taught about during the sessions, so you can go and practice further the topic that you were just hearing about at the session. Yeah, and we would like to say a big thank you for our sponsor, who is Microsoft, and a big thanks for all the graphic design and that you can see at our streams, and then our website as well, that is done by Levente Pongo, and the intro music is composed by Mina Mary, and yeah. And yeah, we are going to yeah, we are going to meet. Sorry, we're going to meet on. Okay, what was the date again? So on the 27th, in the 5 o'clock in the afternoon. So yes, please remember to follow us, and you can hear all the information. So thank you, and we actually have questions coming in, Håkan.
Oh, okay, great.
So let's go back to the TensorFlow topic a bit, because we have some questions like if we have some examples of TensorFlow.js and React, just small code snippets to get an idea on how to implement the TensorFlow.js in React.
Yeah, I can have a look, and I can see if I can post something into the comments afterwards.
Okay, and there was something else. What are the benefits for using TensorFlow.js if you already are familiar with the Python language?
Yeah, so the benefit here is that then, as you can see, you can you can run this thing in the browser, and you can also be collaborating with many more people, with the people, so that if you just run it as a Python in a Jupyter notebook, it can sometimes be difficult if you want to showcase it to many people. But by doing this, you can easily get something out fast and demonstrate it to people what you're doing.
Thank you, Håkan. We got some nice comments that people are very thankful for the sessions today and for your answers as well. And I also want to say a big, big, big thank you for both of you guys, because you did a great session. Let's go. Yeah, thank you, Sammy. Yeah, so yeah, thank you again, guys, for doing these sessions. It was really exciting and really interesting today, and I hope you also enjoyed it a bit.
Yeah, it was great.
Cool. Yeah, I think so. And yeah, everyone who is still here, thank you a lot for joining us. And it was really nice to have you all today. And if you would like to follow us, you can do that. If you can see on the right side of the screen, on the button that says that Global AI Community on Twitter, and you can find our website, the Global AI Community, as well. Please follow us so you can see the coming up sessions as well. And remember to check out the bootcamp page too, because there are a lot more sessions happening today. So go ahead and see if you find something interesting for yourself. Thank you a lot for today.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent Sammy with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I'm Deprez. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Nederlands.
I'm Håkan from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California. Hi, Medin Ali Daoud from Ghana.
Hi, I'm Ana Kamana.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there.
Hi.
Hi.